Welcome to A Trekzone Conversation. I'm Matt Miller. Aussie Space Month begins today and continues for 4 episodes. It's all about the burgeoning industry that the Australian federal government is building and supporting. And our next 4 Trekzone Conversations are all thanks to spaceaustralia.com. My guest today is Dr. Jason Held, CEO of Sabre Astronautics. They've just been awarded 2 big contracts which will pioneer the Aussie space industry.
With thanks to spaceaustralia.com, this is Trekzone's Aussie Space Month. Beaming around the world across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is the 8th season of A Trekzone Conversation with Matt Miller.
Jason, thanks for taking the time to have a Trekzone Conversation. Welcome to the show.
No, it's awesome. It's awesome. Thanks for inviting me.
First up, and I love this industry and astronomy in general because acronyms are so crucial. Sabre has been awarded a grant to develop and build the Responsive Space Operations Centre, or RSOC. What exactly will that be?
The RSOC is a mission control center concept that we've been working on for several years now. And the short end of a long story is Sabre is a space engineering company based in Sydney, and we merged together a lot of machine learning techniques to predict satellite behavior with gaming technology, so you can actually see your spacecraft when you're flying it, and we're merging it together. So the RSOC is the ability to respond quickly to the space environment and make commands very quickly. That's really what the RSOC is. It's responsive. It's responsive to our needs here on Earth. That's really what it is.
Well, that's very cool. And it's going to be the first professional control center in the world, as you say, to use machine learning and 3D gaming technologies. Yeah. How's that going to revolutionize spacecraft operations?
I think it's just going to make it easier. You know, I think part of the reason why I went down this path was because space is the kind of industry which is a very technical industry, and people that are in it love to be smart, and they love people to know that they're smart. You know, so it's kind of like we see space as this kind of unachievable field. You got to be so high to ride the Ferris wheel, and all the tools that have been used before kind of exacerbate that. You know, it's kind of like people who love a complex computer program because it makes them feel smart. It's the same thing with space engineers. A lot of very text-based interfaces. It's kind of like the Matrix. You know, so if you go to like NORAD or if you go to even SpaceX's operations center, which is, NASA says the most modern space operations center in the world, has these very kind of really rich, complex information data. And we're like, it doesn't make a lot of sense. You need a PhD to do that. And if you look into it, you see that people, they need like 6 months to a year of training time before they can, just to use the software before they even start playing with the satellite. So I said, let's turn that around. Let's make it a video game. Because games are really, really good at taking lots of complex information and packaging it in a way which is easy to use. So you do that, and you democratize the operational component of space, so anybody can use it. You can get undergraduates in there. We've had high schoolers playing with space operations tools. It went to U.S. Space Force back then, Space Command, and trained their operator up in about 45 minutes. And,
oh, wow.
Yeah, they were pretty happy. They were like, it rains. That's kind of how this all happened.
Well, what are some of the challenges in building an operation like this, mission control, from the ground up? Are there any lessons to be learnt from other spacefaring nations, say the way NASA built their mission control?
Yeah, I mean, of course, there's 50 years of heritage of people doing space ops, and I've been in the space operations field and the space industry for over 25 years now. So my own background, worked on Hubble and ISS and things like that. And Sabre as a team have worked on medium-sized spacecraft and CubeSats. And I think there are different lessons to learn based on the altitude you're at. So people who are experienced at geosynchronous, like all of Australia's communication satellites, are going to be a little bit different from people who work in low Earth orbit. But there's a whole lot of lessons learned in terms of what could go wrong, and how you handle what could go wrong, and how you diagnose the problem. And I could go really deep into there. I don't know how much time you got. I could go on all day about this stuff. So what do you want to know?
Well, it really is just those challenges in establishing mission control and I guess it's pioneering what Aussies are going to be doing, looking after Aussie missions. And I guess it really comes down to what Australia is going to be contributing to the spacefaring society.
Right. All right. So the first thing you need to know is space mission control encompasses a couple of things. One is you want to be able to control the satellites that are in your inventory. Okay. And mission control, that's exactly what it is. Eventually, when we start having astronauts, which we better have some astronauts in Australia, then you start adding a different component such as public relations and things like that, and astronaut health, things like that. So it's about diagnosing the actual assets you have up there, sending it commands, and it's also about keeping it safe, which implies space traffic management, which is a fairly new field because of the way the space industry is growing. So what we're going to be doing over the next 6 months is we're going to be setting up the data streams for space traffic management, which means telescopes and sensors and radars and things like that, directly into the operations center. And we're going to be setting up relationships with dish operators so that when the satellite flies over a dish, you can send it information and you can receive information, send it commands, and that kind of thing. Those are really the basics.
Well, in my field as a television master control operator outside of Trekzone, we look after terrestrial TV broadcasts and terrestrial transmission of data and video and audio as well. Moving into the field of IP now as well, internet protocol, instead of the old days of coaxial cable and long runs of satellite links and all that sort of stuff. So I guess it's really fascinating for me as well that this is from the ground up. We're building space communications. It's beyond what I was doing looking after TV. Now it's looking after these big missions in orbit, as you say, potentially with Australian astronauts. Our spacecraft has to be codenamed the Kangaroo, surely, but getting them up into orbit and talking to them and making sure that they're alive and well for the whole time. So it is quite a crucial operation that Sabre's engaging in here.
So Kangaroo, maybe we ought to change it from RSOC to KSOC. Should we do that? Want to do that?
I think so. Yes.
Yeah. Look, I mean, it's look, you've got trillions of dollars worth of assets in space, and it's you got the people side of it, but you also have the machinery. Space information manages pretty much everything we do. It's a data information highway of the 21st century. So I think Australia is growing very quickly in the field. We've got 400 new satellites that are commissioned and funded for manufacture for the commercial sector. 400 just in the next 5 years alone. And if you think about that, as a species, we only have about 1,400 satellites in orbit today.
Oh, wow.
It gives you a sense of how quickly this is growing. It also gives you a sense of how things are growing in Australia. But
Australia's playing catch up, it seems.
Well, in a way we are, but in a way we're not. Yeah, because we talk about like ground stations and dishes and things like that. And Sabre doesn't. We don't build our own dishes. We never built our own dishes. We don't want to. Mainly because there's plenty of Australians that are very good at that anyways. And if you think about it, Australia has always been kind of a really rich place to have ground station infrastructure. What we're doing is we're tying it all together into an operations center. That's all we're really doing.
Well, let's move to another acronym, the OSSO, or the Open Source Space Operations Project, which is aiming to make it easier for new Aussie space companies or space companies in general to deploy their missions. It's another grant that Sabre's been awarded. What exactly are the goals for the OSSO?
Well, say also is a project that we came up with because we've been building the infrastructure, the middleware, to connect dishes to our own operations center for the last 10 years. And whenever we have a new customer, a new satellite that's got to fly, we always kind of hit the same pain points. First is everybody gets vendor locked to the same software and the same satellites, right? So if you buy a little piece of a satellite, then you have to buy everything else down the chain, and all the data infrastructure is set only to work with each other. You end up getting siloed, and I think this holds the industry back. The other is a quick way to kind of connect them together, because if you got a satellite in space, it's kind of like driving a car, but you got all this information that's got to pass through. Now, if you remember with the Mission Control Center, we said we want to abstract all that information into a video game, but you still got to have that information come in. And it still takes quite a bit of labor to annotate each one, put it in a database, track every little register on that spacecraft. So we run into a lot of teams, especially here in Australia. You got really, really good mechatronics in Australia, really world-class mechatronics, and good space engineers. They design their spacecraft, they build it, they raise some funding, and before they start to launch it, then they start thinking about operations. And they don't have a whole lot of time to put it together. So we're going to make this open source toolkit called ASO that anybody can plug in and add their own infrastructure on top of, save them months and months of time. That's really the intent.
Well, there's one key mission already slated to benefit from OSO. It's the Tolleman spacecraft. What exactly is that one?
Tolleman's awesome. Tolleman is a spacecraft. It is a telescope that's going to be looking at Alpha Centauri, looking at habitable planets. And the organization that's running it is the Breakthrough Initiatives Foundation, which is out of California, that's looking at the future of interstellar missions and really putting a lot of money on the table for that. But they're also collaborating with the University of Sydney, who's doing a whole bunch of the astronomy science on the back end. So University of Sydney is going to have their own payloads on there. We're going to add some rideshare on, so other Australian centers can get on board the Tolleman spacecraft as well. And then we're going to operate it out of the Mission Control Centers using ASO.
Well, that is very cool and something to look forward to. And one thing that I was reading in the press release from Sabre is that, and Dr. Brad Tucker, who is our co-host on Talk and Science, our other podcast, talks about just how much time is not available with the big telescopes like the James Webb and Hubble especially, which is, it's booked out for months in advance with all the big projects that it seems like projects like Tolleman as a smaller telescope are sort of needed to fill in the gaps in the sky that we could be looking at. There's so much out there to be looking at and just not enough available hardware to be doing that. And I guess that's sort of where Tolleman is slotting into all of this.
Yeah, 100%. And I want to go deeper into that actually, because one of the things I'm really passionate about is what I call the democratization of space, which means anybody, anywhere of any educational level can be a part of the industry that we love. And if you're going to send a telescope into low Earth orbit to look at stuff, we have very few pipelines for these types of assets. So only people with very strong academic credentials and science capability can get access to the imagery to do science. I want to see a lot more citizen science, and especially Australians doing citizen science.
And there's a lot of discoveries made by citizen scientists and citizen astronomers purely because, as we're talking about here, there's just so much out there to look at and not enough time to do it. And that's where it really is a benefit for humans or human knowledge and understanding.
Yeah, absolutely. Us people, anybody should be able to get access to it, and it's not an easy thing to do normally because you spend a lot of money on it. I mean, Hubble's a major infrastructure, multi-billion-dollar project with federal funding. So it's very hard for any citizen to get on board and schedule some time. So if you say, I want to look at this object in space, how are you going to do that? Who are you even going to call? I mean, that's the thing. Like, who are you even going to send a request to? There's no person you're going to call JPL and be like, hey, Joe, how do you do that, right? So that little bit is something we want to fix with the RSOC, but the way to connect to it is what we want to fix with ASO. That's how the two projects fit together.
And it's not just Sabre working on the OSO either. There's a collection of organisations as stakeholders in this operation, in this open source project.
Yeah, well, I mean, it's open source, so we want everybody involved at the end of the day, right? Anybody who has a satellite that needs help connecting to dish, it doesn't even have to be ours. We're not going to be, but we'll make plenty of money other ways. We want to have this as free, it's open source. So you're gonna, the more people that are in it, the better it's going to get. It has to be a community project. So we're going to be running around Australia doing these workshops in every major city. And we're going to invite people in to play with it and to give feedback and find out how, everybody can get involved. That's really what we want it to be. This is going to be the ultimate citizen science space engineering project.
Well, this certainly is an exciting time for the Aussie space industry, and it's only going to get busier. Dr. Held, where can people find out more about Space Sabre or Astronautics and especially the open source project?
Well, our website, sabreastro.com, is going to have all the information you're ever going to need. And the websites for also is going to be attached right to that, and we'll certainly be letting everybody know very soon how to do that.
Fantastic. And of course, Trekzone is all over social media. Just search for Trekzone. We're going to have more of this. Aussie Space Month continues next week, which is going to be very exciting. Dr. Held, thanks so much for having a Trekzone conversation today.
Thank you very much. Absolute pleasure.